Good morning. Today we will discuss about multi-threading concept in Java, and it comes under fourth unit, the first chapter, and this is the syllabus which we are going to cover in this multi-threading concept, and which is represented in red color. First, we will see certain topics in this. What is meant by multi-threading? So multi-threading is a thread is having more than one thread in a particular program. So a part of program you can call it as a thread, and you can run more than one thread concurrently using this multi-threading concept. So Java provides built-in support for multi-threaded programming, and sometimes you can name it as a multi-threading is a specialized form of a multitasking. So usually the multitasking done in two ways. It may be a process based or thread based. So in operating system we come across this process based multitasking. There we can have more than one task parallelly we can run. So a process is essence a program that is executing. So we can run more than one program run parallelly one after one. At any particular instance of a time, only one process will be inactive. But we feel that the two or three process will run parallelly, and this comes under process based multitasking. The best example is you can run Java compiler at the same time you can use a text editor, or at the same time you can play certain songs and all. In process based multitasking, a program is the smallest unit of code that can be dispatched by the scheduler. So here every program we can consider as a separate process, and the dispatcher or a scheduler is going to be dispatched based on that particular uh, process. And moving from one process to another process, we can call it as a switching or context switching. And these things already we come across in operating system. And coming to thread based, a thread-based multitasking environment is a thread is the smallest unit of dispatchable code. So here a thread, a part of a program, is the smallest unit where the dispatcher is going to be dispatched this particular part of a program. A single program can perform two or more tasks simultaneously. So imagine that a program will have certain huge code, and you can create more than one thread to execute a part of program. That particular part of program is going to be handled or run by that particular thread. At any instance, only one thread will be active. And you can take a simple example. A text editor can perform can do certain things by typing or something, and meantime you can also print that particular text. So only one program is able to update the value, and you can also can take a sort of printouts by using a different thread with this. And we will see the next one. And there's some of differences between multi-threading and multitasking based on process and thread oriented. So multitasking threads requires less overheads than compared to process. Why? Because process will have its own address space, and every process having their own memory, and every time we need to change the memory address spaces. But here in multi-threaded, it uses a common or shareable address space, so we can easily communicate having the same address space. Two or more threads can easily share the same address space. And inter-process communication is somehow expansive, and overheads will be takes place in inter-process communication, a process to process communication. But in inter-thread communication is inexpensive, and you can have switching done by means of one thread to another text in a lower cost manner. While Java program makes use of process-based multitasking environments, process-based multitasking is not under the control of Java. So it is not in the control of Java, it is in the control of operating system, but here multi-threading is in the control of Java itself. The next one is multi-threading is why we go for multi-threading in the sense mean we can use maximum usage of CPU cycles. We use this multi-threading. So at any instance, a thread is think that the program is only one thread, single threaded. The particular program is going to be wait for certain IOs. Say for example, user is entering certain value. The thread is suspended there itself for certain period of time until unless user entered a value. But here it is not the case. The program or a part of program is suspended for IOs and the remaining part of program is going to be executed. So here we are utilizing maximum usage of CPU. And we'll see the next one. Next topic is Java thread model. Usually Java will have two types of threads, a single threaded and multi-threaded. As far as the programs we covered so far comes under single threaded applications, and from now we will see how to create one more thread in a program, and two or more threads can run parallelly. And in fact Java uses threads to enable the entire environment to be asynchronous. So here we are having two notations, synchronous and asynchronous. Synchronous in the sense two threads will have a synchronization, one after one will take place. In asynchronous it is not the case. At any instant any particular thread is suspended, the next thread which may not be in the queue will come directly based on its priority, based on its state. So asynchronously the threads will use the CPU and execute the remaining part of the program. So next one is single threaded model. A single-threaded model uses an approach called an event loop with polling. So what it means there is a loop, infinite loop will be takes place. Continuously it is monitoring the program where an event is occurred. So at any stage, at any particular part, an event occurred. Event in the sense some what you can say. Some event like user is waiting for certain IOs, the IO is entered, or user may be waiting for any network, the network is able to use. Such things comes under events. The event is ready, I mean the particular thing is ready, then the polling is takes place, and the polling mechanism returns with appropriate dispatcher to handle that particular event. So think that the user entered a value. So now IO will come into the picture. Now the part of program will take place from that particular onwards by accepting a value. So until that it is simply waiting. So it is in a continuous loop that waiting certain values, certain events. Once an event occurred, once a value is entered, once a network file is ready to use, so now the handlers will come into picture and make use of that one. So here it takes certain huge amount of time, simply it wastes the CPU time, and it simply blocks a thread to wait for certain resources until certain things happen. The entire program stops running until unless the value or the resource is handled by the handlers. Coming to multi-threading model, so it is not the case here. There is no such continuous looping or continuous monitoring for a resource, and here it is not the case, and we are having more than one thread will be there, and at any stage one thread is blocked, the remaining part of the program is going to be executed by the remaining threads, and all threads are continue to run. So this is the main advantage of using multi-threading concept. And the next topic is simply the states of threads. It is as same as process transition diagram in operating system. Their process will have more than one state. It may be in running state, it may be in waiting, it may be in block, and so on. Here also the same, the thread will have different states. So usually the thread may be in running. So whenever thread enter into the CPU and it is make use of CPU time and it is executing certain block of code, you can call it as a running stage, and it can be ready to run the next stage is. So think that in that situation the thread is eagerly waiting for the CPU and it is ready to run. And the next one is suspended state. So whenever a thread is suspended temporarily by waiting certain resource or by waiting for IOs, or sometimes it may be called some sleep methods and so on. And sometimes the suspended thread can be resumed, allowing it to get pick up where it left off, and it is resumed back and make use of CPU and get ready to run state. Once the CPU is free, idle, now it is enter into the running state. And the next one is a blocked state where it is waiting for certain resources which is already occupied by the another part of threads. At any time, a thread can be terminated, so which halts its execution immediately, and once terminated, a thread cannot be resumed back again. And we'll see a simple diagram of life cycle of a thread. Here we are going to be create a thread with thread class or by using runnable interface, and we can create a thread. The thread newly created thread will have one method with the name of start, which is going to be called. The system will enter into the thread enter into the runnable state. It is ready to run state, and internally it is going to be called the run method. The run method, once it is called, now it enter into the CPU and make use of CPU time, and it is in running state. So there we are having two more states. One is dead and another is waiting. Now waiting block or state is where we are having certain wait method by waiting for a resource, or sleep method to suspend certain period of time. It entered into the waiting state, and it is resumed back to the running state based on the CPU schedules. And whenever it is entered into the dead state, or it is a terminated state, that process never resumed back. So these are the information regarding to this. And thread priorities. So one more simple topic here. Every thread newly created by the thread class or runnable interface, the thread will have usually certain priorities. So based on the priorities, the thread will execute. And here we are having one integer value which will which will represent the priority of thread ranging from 1 to 0. And you can also represent the same by means of certain keywords. And here one word context switch. The thread priority is used to decide when to switch from one running thread to another. This is called context switch. So context switch in the sense a running thread is suspended and another thread will come into the CPU. That moving from one thread to another thread, we can call it as a context switch. And these are the keywords which we represent for priorities: min underscore priority, max underscore priority, and norm underscore priority. These are the constant words to represent priorities. So usually a normal priority will have the constant value 5, and the minimum priority is 1 and maximum is 10. So within the range of 1 to 10 we can fix up the priority of that particular thread. The priority never guarantees that to execute faster. Simply based on the priority which a thread will have more highest priority will get a CPU resources at earliest, but not the execution speed. Right, so take a simple example. Whenever any hardware error occurred, the system will directly show that hardware information rather than the things happening. So the hardware errors having highest priority than compared to the software things. And one more thing is here, when the context switch takes place. The rules that determine when a context switch takes place. Usually the thread can voluntarily relinquish control. So at any stage the thread is what can say yielding or sleeping or blocking or unpending of IOs. So the thread will voluntarily disconnect from the CPU, or sometimes with a high priority thread that is ready to run is given the CPU automatically. The second one is a thread can be preempted by a high priority thread. So whenever any thread which is having high priority, it has to execute before this particular running thread. So at the time it simply preempted the running thread, and the CPU is going to be handed to the high priority threads. And so one more situation takes place here. Whenever two threads will have the same priority, usually this is a somehow complicated situation, and whenever you use Windows operating system, such type of priorities are going to be handled by round robin fashion. And whenever any other operating system other than Windows, so it depends on voluntarily yielding control of their peers, depends on the situation. And the next one is synchronization takes place. Java supports a synchronization of multi-threading. Any number of threads can run simultaneously without disturbing other to access individual resources at different instance of time or shareable resources. but sometime it may be possible that shareable resources are used by at least two threads. Say for example, one thread is writing certain information and another thread is reading from the same. So in that situation, uh, some unwanted situation rises. So we need to synchronize these two threads. So one has to write the data and another has to wait. And whenever one thread is reading data, the other thread has to wait. Such things, such monitors are takes place by means of this synchronization. Such things we can call as monitoring, and this is given by CA Hoare. The monitor was first defined by CA Hoare. You can consider a monitor as a box, just like a box where one thread can reside in, another has to wait outside of that particular monitor. So in such a way, monitor protects the shareable resources used by it being manipulated by other waiting threads. Java provides a simple methodology to implement synchronization. So the overall history of this here, one thread is using any shareable data. The remaining threads has to wait until it what you can say relinquishes the data. And next topic is messaging. So these are the only simple definitions here. Messaging in the sense, two threads can communicate with each other. Just like inter-process communication, two processes can communicate with each other. Like that, two threads can communicate with each other. So whenever thread is in the monitoring in the monitor, whenever it simply come out or exit from the synchronization state, it has to notify all the waiting threads. So based on the priority, the thread will enter into the monitor and executing the resources. So this is a simple scenario happens in this, and we will see the remaining topics later.